Hey everybody, it's me, Alex Merced, and we're going to be doing a presentation on ZeroETL and Virtual Data Marts. Basically, just talking about like what are the main pain points in building out your data infrastructure, and how can we get rid of those frictions? Okay, because so what do I hear when I hear the words ZeroETL and Virtual Data Marts? I'm thinking no copies, and that's kind of where we're going to be going. So first, let's kind of just talk about that pain and that vision of sort of where we're going. Okay, so if you take a look at sort of like the world of data today and where things have been, you have all your data sources. Okay, bottom line is you probably have an application or a business, and you have lots of data systems that are meant for the operation. You know, to look up customer records, for people to log into their accounts. Um, all sorts of different things, whether it's a SaaS app, on-prem applications, custom applications, enterprise data, business applications, IoT, third-party data. You have applications that engage databases for your operations. Now you want to start using that data for analytics, so you can discover insights for as like, helping you predict what you should be doing as far as purchasing inventory, or how you should be investing your money as far as the growth in your business. Okay, predicting where the best place is to go and promote your business, where are the areas for growth. You need data to kind of develop these types of insights, so you want to move your data into analytical to data analytics. And that requires lots of different systems, such as data lakes being sort of this big catch-all repository of data. Okay, that can be done across clouds, on-prem, using things like Hadoop, or in the cloud using like AWS S3 or Azure Data Lake. All these things are great. And then again, you're able to put your structured and unstructured data all there in one place. But oftentimes to do that, you have to write ETL pipelines, aka code that you run that extracts E from your data sources. So it basically pulls the data out, transforms, so basically makes some changes to the data so it's more ready for how you're going to use it on the other side, and then loads or lands the data in that target destination, aka in this case, your data lake. So you're gonna have all these ETL pipelines, and oftentimes it's not a straightforward point A to point B. Oftentimes there's many intermediate steps. Okay, you may land the raw data, then you have a pipeline to then basically clean up that data. But then once you have the cleaned up data, then you may have other pipelines to join or denormalize that data. And you go through all these layers of changes. And each time you go through one of these layers of changes, you're making physical copies oftentimes. Okay. And in order to get that final result, each of the previous pipelines have to play out. So this becomes this really unwinding chain. If you've ever seen something like called a DAG, a directed acyclical graph, you can kind of get an idea of how complex these changes make, where you're trying to track, okay, which changes should happen first and what order. And the thing is that once you get all that data curated in the data lake, some of that data's got to move over to a data warehouse, okay? Because oftentimes that's going to be your front line of data analytics. So you take that subsection, that sub portion of the data that you've curated in the data lake, and then you make more data pipelines, more ETL pipelines that extract the data from the data lake, transform it again, and loads it into the data warehouse. And then within the data warehouse, you're going to create a whole bunch of data marts. Okay, so basically little mini warehouses in your warehouse. There's the central data warehouse, and then all the little mini warehouses for your different business lines. Okay, um, and then there you're going to go through more layers of transformations for specific use cases, and again more copies, and then everything becoming dependent on this big long chain of pipelines across all these stops. Okay, and then all this data is going to be used to fuel BI dashboards, custom applications for like data analytics, self-service data visualizations, data extracts. You're serving all this stuff, which some of that ends up also pulling data from the data lake. So basically, you have data sort of moving in all directions, all sorts of copies that are interdependent of each other. And this kind of creates a lot of headaches because you have to write the code and maintain and deploy the code that takes this long chain of steps and make sure that they always are consistent. Okay, and that's a lot easier said than done. But also at times you also run the risk of having so many copies that you can't kind of track what changes are being made. Are things like adhering to sort of your data contracts or business models, or your basically the things that you expect, and so forth. Okay, so what's the problem? Okay, when one pipeline breaks, it causes every other pipeline in the chain to break. And that means you have to go back and fix it. That means removing the bad data, replacing it with the right data, aka backfilling, which can be very tedious when you don't have the right systems in place to make that kind of disaster recovery easier. When you get to bottom line is that it takes time for each pipeline to play out. So the more complex this long chain is, and the more copies that have to be created, okay, the longer it takes for the data to get to that end user, that data consumer, and they get angry. They get angry because they're not getting the latest data to make accurate decisions based on. And a lot of times maybe that data is wrong because there's just so many different places and so many points of failure along the way. Whew. And on top of all that, just on top of just sort of the tedious backfilling and the angry consumers, there's also just the cost of it all. Okay, you're paying every copy, you're paying for more storage. Okay, um, every time you run a different pipeline, that's more computing power that has to be used, and you pay for those cloud compute instances. So the longer they run, the more you pay. And then when you're moving data outside of a particular cloud, oftentimes you're paying egress costs. So you're paying to move the data outside, from, let's say, your data lake into your data warehouse. On top of the compute you cost for those ETL jobs and the storage for landing that data in the warehouse that you already had in the data lake, you're also paying all those egress costs, the cost of just moving the data out of the system, and then a cost of moving data within the system. Okay, and then just a lost productivity. Like you could, basically, while this data is proliferating, there's just stuff you can't do. Okay, because you're waiting for the data to get there, and then also the time that you're spending building all these pipelines that you could be spending curating new layers of data, new use cases. Okay, all the regulatory fees because, oh no, I forgot to mask the PII on this one view of the data, and now I get regulatory fines, so many different security risks, and making sure that all the access for all these data sets in different places and different places of access are governed. Okay, all of this kind of really adds up. Okay, and then there's a situation where basically your data models are shifting. So many transformations to these columns and rows and whatnot, that things move away from what the data was originally meant to represent, resulting in bad insights. And then just the cost of making bad decisions based on the wrong data. Okay, so there's a lots of things that can go wrong in this setup. So the idea is I can minimize a lot of this if I can just minimize the number of pipelines I have to build, maintain, and deploy. Okay, one is going to reduce the amount of time I'm focusing on just doing what we already have instead of building what can be, but it's also going to reduce my costs, make my end consumers more happy, whatnot. Now, how do we do that? And this is kind of where we get to sort of like the Dremio approach, the ZeroETL Virtual Data Mart approach. So ETL is the movement of data. So you creating these pipelines. So again, you writing the code, you deploying the code, and then maintaining the code through updates over time. Okay, ZeroETL means we can minimize your need to do that as much as possible. So ZeroETL means basically reducing the number of pipelines you have to write as much as possible. Ideal world zero, but close to that as possible. Virtual data marts. Okay, so basically, once the data got to your data warehouse, you built all these data marts where you modeled your data through layers of physical copies. Well, virtual data marts would mean we achieve the same thing without layers of copies, but just through layers of logical views of the data. Okay, so if I do these two things, okay, if I model my data virtually and I minimize the movement of the data, technically there's very little in the way of pipelines I have to write or maintain or deploy. But how is that possible? Okay, so let's kind of establish sort of what this is. So bottom line is you would take your data sources, and at best you might have export load pipelines, meaning you just land your raw data in a data lake house. The difference being the data lake house is you just have your no data warehouse. You just have your data lake. You store your data on the data lake, and you use tools like Dremio, Spark, Flink to interact with that data in your data lake to fill the gap that the warehouse used to fill. Or, you offload more and more of what you do in the data warehouse onto this data lake house pattern. The idea of treating your data lake as your data warehouse. Okay, particularly enabled through data formats like apacheiceberg and datalake that allow tools like Dremio to interact with your data lake like it's a database. So basically, you can either connect your data sources directly to a platform like Dremio, or land your data in a data lake house and connect that to Dremio, and then that delivers your data directly to the clients. So basically, you're just moving the data once. You're just moving it to your data lake, and that's if you even do that move at all, because Dremio can connect directly to your operational sources if need be. And then you just deliver that data directly to your clients. You don't have these layers and layers of copies that you have to build out, because all that's done through, again, we connect all that data We federate it. So again, that could be you connect your data lake, your databases and data warehouses directly to a platform like Dremio. So in that case, you have very little ETL. You either have zero ETL because you didn't move any data, you just connected the original sources, or maybe you just did one movement of your raw data into a data lake. So you have low ETL, and you're going to allow everything else to be handled logically through logical views. But then you're going to use Dremio semantic layer, where you can create all these layers of logical views and model your data like you would in a data warehouse in the same way you would build data marts. But instead of making physical copies of data, you're just creating more layers of logical views in the data. And Dremio has very, very high capability for creating very complex layers of views, okay, so to make that practical. Now, usually where people get caught up, because, Dremio is not the only tool in the world that allows you to make logical views. So why doesn't you just use any tool to make logical views? Well, where you usually get caught up is performance. Okay, usually you want logical views. Okay, they're much more lightweight and they're much easier for self-service. But oftentimes you're still operating on those same original data sets. And if everyone's carrying the same original data sets, doing those full table scans, that's not necessarily the most performant thing in the world. And this is why you end up creating all these chains of copies and whatnot. And we'll have a quick example of that a little bit later on, but it becomes very messy. But Dremio unlocks the key to making this practical through its features like data reflections. Okay, this eliminates the need for like materialized views, cubes, extracts, all these complex webs of copies that you would have to manually curate and maintain get thrown out the window with the difference of the flipping of a switch. Okay, making life a lot easier. What's the benefits of this approach? Okay, one, less pipelines that you have to write, the less pipelines that are going to break, so less backfilling. Okay, at the end of the day, basically Dremio is going to abstract away a lot of the pipelines you would have written. In the places where maybe some sort of acceleration is needed, Dremio is going to kind of abstract all that away. You just flip a switch and just enjoy performance, and you just enjoy that your data is getting where it needs to be. You just land that data, you model it logically, and let Dremio handle the rest. So that data is going to land there quicker because you're not going through as many hops of physical copies, and which means you're going to have to do a lot less fixing and curation. Your users are going to get that data faster and fresher, and it's going to be more correct because, again, it's much easier to think through doing things right when there's less steps than when there's more steps. And on top of it, you're going to save a lot of money, okay? Less copies, less storage costs, less pipelines, less compute, less data movement, less network costs. You're not having all this egress because you're not moving data into a data warehouse. Less pipelines, more likely the data stays fresh because you don't have so many versions of the data that need to be updated all the time. Okay, less copies and more copies. And well, if you have less copies that are in only one place, then it's easier to comply with regulations. You're less likely to accidentally have PII exposed somewhere. Okay, your data models are less likely to drift. Your data is going to be fresher. So you're going to have all these benefits because you're simplifying. The key benefit here is simplifying. But the question is, how do you simplify and still maintain performance? And this is sort of where Dremio really unlocks the key. It allows you to simplify at scale because Dremio handles the performance piece. And it's going to allow you to get all these benefits when everything is said and done. Okay, again, how does Dremio make this all possible at scale? Okay, it's two things. High performance. Dremio is designed to try to find ways for performance and intelligent. And again, the key word is intelligent performance. It doesn't expect you to have to turn all the knobs and set all the dials to get performance. It's going to try to handle as much of that intelligently as it can for you. So that way you can focus on modeling and through virtualization and working sort of when it can, working with the original data source. So that way, you don't have this complex web of physical copies. So through high performance virtualization, okay, so again, anchoring with the idea that we want to virtualize as much as possible, but coming up with the abstractions to provide performance, we make this scalable, okay? Because a lot of times you have other platforms that say, hey, we can federate a lot of data sources. Hey, you can virtualize your warehouse through logical views, but you get stuck with performance because a lot of times going back and sending those queries to those federated sources for every view on the data ends up not necessarily like working as well as you'd like at scale. But Dremio, again, addresses that pain point. One way it does that is just that Dremio is fast. Okay, Dremio uses Apache Arrow for processing. So what is Apache Arrow? It's a in-memory format, meaning how data, when data is loaded from wherever source you have, loaded into memory and processed by Dremio, it's in this standard open source format. The Apache Arrow format, actually in its earliest stages, was the in-memory format for Dremio. So this is a project that very much came out of Dremio's efforts. And basically by creating this sort of standard format that's basically allows you to kind of represent more data in less space and do it in a columnar way, which lends more to analytical processing, you're going to get faster in-memory processing. And through things like Gandiva, that allows a lot of processes to be pre-compiled the binary, okay? And then also fast transportation of the data through things like Apache Arrow Flight, it allows that data to be now processed and moved very quickly, okay? So even out of the box with the federated sources, Dremio can probably outperform most other engines just based on pure sort of engine power alone, okay? Also, another open source project that Dremio leverages is Apache Calcite, which is generally used for like SQL parsing. It allows for like cost-based optimization. So sit there to be able to come up with different sort of SQL query plans and figure out, hey, which one's going to be sort of the most cost, basically the most performant and reduce your cost the most. Be able to create custom rules for that way it'll constantly improve your SQL queries and optimize them for you, and do a lot of that kind of work for you. So that way, even if you don't write the best SQL queries in the world, they can still perform like they are to the extent that they can be optimized. And then there's reflections. Like reflections are really, really like the secret sauce in Dremio, okay? Because essentially they make the need to create this web of physical copies less necessary, okay? And there's two categories of reflections in the Dremio world. There's raw reflections, and raw reflections are more basically, they kind of fulfill the role that you typically see with materialized views. So with materialized views, you would create a physical copy of a query result. So you'd query a table and you'd get like a subset, and you would materialize that, aka make a physical copy of that. Now that physical copy wouldn't auto update, so you would have to kind of figure out how to keep that up to date and fresh. You would have to write that pipeline, maintain that pipeline, deploy that pipeline. Okay. Also, that physical copy would be under a different namespace, so your users would have to know to change their queries to query that other name, which can be really, really tricky. But with raw reflections, all you do is, so again, you, instead of having this big web of physical copies, you would just have your tables and you would just create logical views on those tables. And in this case, the join might be a good thing you would normally want to materialize, because joins can be very intensive. So instead of having to run this join, so if I want to query view B, instead of it having to do the join, okay, and then do the subquery every single time I want to query view B, it'd be nice if the join was already pre-computed. Okay, so by just flipping a switch, the reflection switch, that's going to be pre-computed. You're going to end up basically having that materialization of the join in an iceberg format, which allows there to be some more advanced like partitioning and sorting benefits to it and some indexing involved. But basically this nice optimized version of that subset of the results. And it's going to be auto-maintained, so Dremio will track to update it. But now when I query view B, I don't have to like query like a different name, or if I want to query this joined view, I don't need to query another namespace. I just query it. Dremio is aware of this pre-computed, this summary, this materialization, that it exists. Dremio tracks these. And not only can you have Dremio make them, but you're able to bring your own to the table. So you can actually create your own materializations and register them with Dremio, so Dremio can be aware of them. And when Dremio notices that you're querying these data sets, it can then swap out and say, okay, don't use these physical tables. Let's not go through that whole process again. Let's just use this materialization. The end user doesn't even have to be aware that this is happening. Dremio will just see the query, be aware that these physical pieces that it can use to optimize the query, and it will intelligently do that for you. Okay, so Dremio is constantly intelligently finding ways to speed up your query, so that way you don't have to spend as much time thinking about that and spend more time thinking about how you model your data and the questions you are asking of your data. Okay. So again, it eliminates a lot of the headaches you have there. But then there's also aggregate reflections. So when it comes to like aggregations, which are typical for like BI dashboards, because when you're creating a dashboard, usually what you're seeing in those charts are the results of like sums, maxes, mins, all these types of aggregate calculations. So typically what would happen in the past is that you would pre-compute these aggregates through creating manually BI extracts, cubes. These would just be data structures where you pre-computed all these numbers, but you did it yourself. Again, you have to write, maintain, deploy these pipelines yourself. So that's more work for you. Okay, again, they don't auto update, so that you have to make that logic. And then generally, oftentimes when you rerun it, you're making an additional copy. So every time you rebuild that cube, you rebuild that extract, you're making an additional copy. So that, and then you have to make sure you swap out the dashboard to point to the new version of the cube and the old version. Okay, so you have this really massively building storage of all these copies of the cube. You're having to do all this manual work to keep all your BI dashboards pointing to the right version. Okay, so it's just a lot of work. And oftentimes these things can get so large, they can cause memory issues that you would have to figure out on your own. Dremio takes care of all this for you. Dremio will create these pre-computed aggregations as a reflection. So again, this will be sort of a iceberg data structure, or basically Parquet files with iceberg metadata, that will have all these aggregated statistics pre-computed, and it will swap out when it sees those types of queries to that data set. So in that case, instead of having to build a BI dashboard specifically on using a cube, you just build it on the relevant table. And if Dremio is aware of these reflections, it'll swap them out. Dremio will make sure those reflections stay up to date. You don't have to write any pipelines to maintain, deploy. Dremio will handle it. And again, Dremio will handle sort of like the structure of this data structure for, and how to handle and how to read it, to avoid sort of memory issues when the Dremio query engine is processing these reflections. So with raw reflections to kind of replace that need for those manual materializations, and aggregate reflections to replace the need for BI extracts and cubes, it just comes down to you just flipping a switch on data sets where you need these. And Dremio is essentially building the pipelines you would have built yourself for you. Okay, so it's not that the pipelines completely don't exist, and that there's absolutely no copies at all, but you build fewer copies because you only need them where you need them. How do you know where you need them? This is where Dremio also enhances with its new reflections recommendations feature. Dremio will be monitoring the performance of your Dremio cluster and the queries that are coming in. And if it notices that there's queries that could be faster or should be faster, okay, that can be enhanced through a reflection, not only will it tell you, hey, you should have a reflection here, it'll give you the SQL to run to create that reflection. So basically, it'll, for the most part, spoon feed you what you need to do to keep everything nice, fast, and fresh. Okay? Again, the idea is that Dremio is going to be as intelligent as possible in order to kind of abstract as much as it can away from you. So that way, again, you can focus on modeling. You can focus on what your data models should be, your analysts can focus on what the questions they should be asking. But also to enhance performance, because we mentioned that one of the other costs was like that whole egress cost. So imagine that if every time you ran a query, okay, we had to go fetch that data from your cloud storage, you could be hitting all sorts of different network costs and egress costs, moving that data back and forth. What Dremio does, if it notices that certain like things in your object storage are accessed very frequently, the nodes in the Dremio cluster have a C3 cache, the columnar cloud cache. And what it's doing, it's caching the different Parquet files, different row groups, basically whatever it sees that is accessed frequently enough. So that way on future queries, it doesn't have to go make that trip to your object storage, saving you those API calls, which can reduce your costs for your cloud quite a bit and also increase the performance of your queries. So you have the reflections, okay, which are generally going to be materialized in your data lake, but then you have your columnar cloud cache on your Dremio cluster that prevents the need to constantly go to your data lake when not necessary. And all of this continues to kind of accelerate the performance of and make that virtualization at scale possible. Okay, because it takes things that you would have had to do otherwise and takes all the difficulty out of them and takes the visibility out of them. So basically, you don't have to be thinking about, oh, there's these 10 different versions of this data set. There's just a table. And if there's a reflection that would better serve your query, Dremio will know. Dremio will swap it out. If we have something cached that can help speed up that query, Dremio will know. Dremio will handle it. You just focus on what is your query. Okay. On top of that, you have unlimited concurrency, okay? In the sense that basically you can scale your Dremio clusters. So if you're using Dremio Cloud, you could create rules that say, okay, how many replicas of a cluster can exist at the same time? How long would they exist? So that way you can make sure you can always support the number of queries that you expect to have. You can create different levels of clusters. You can create smaller clusters, more powerful clusters, and then route your queries so that way high priority queries go to your more powerful clusters and your more powerful compute, while your lower priority queries can go to cheaper, less performant compute. So that way you allocate based on what your priorities are instead of everyone kind of fighting over the same compute, okay, and paying top dollar for queries that don't necessarily need top dollar. So in summary, and then actually one more note about the scaling is that if you're using Dremio software, if you're using the Kubernetes deployment, there is in the Helm chart, there is the ability to scale the nodes. So you can create rules where it'll add and subtract nodes to scale up your cluster and scale down your cluster based on your rules. So whether you're using Dremio software or Dremio cloud, you have options for scaling. Okay, and because of all the things that I've talked about, you're eliminating most of those ETL pipelines, because most of the pipelines you would use to create these layers and layers of copies get replaced with virtual modeling, okay, layers of logical views and reflections that basically create the physical summaries and caches that would be needed to make those performant without making the use of them more complicated. Okay, and you don't have to basically it eliminates a lot of the maintenance because Dremio is maintaining a lot of this stuff, updating it automatically for you. You have the semantic layer again that allows you to create those layers of logical views across your different business lines in the same way you would model data marts in a data warehouse. But you can also govern it and have really tight governance rules. You have all sorts of things lending to performance, whether it's the high performance query engine, the columnar cloud cache, the data reflections, all allowing you to again have that high performance virtualization along with that unlimited concurrency. Bottom line, less pipelines, less costs, like it's less work you have to do building, maintaining, and deploying pipelines. The more work or the more time and resources you have to focus on modeling and expanding the reach of your data. Okay. So again, when you think about like, hey, if you had an extra X number of dollars to use, what could you do as far as investments in your data infrastructure or your headcount? Okay. If you had more time, what projects could you be spending more time on that would provide new business value versus just maintaining what you already have? These are the benefits. These are the transformations that adopting Dremio can give you. Now, again, just to kind of drive this point home, let's just take a moment and kind of look at the whole story from a bird's eye view on understanding why Dremio is this intelligent query engine. Okay, so again, we're talking about, hey, ideal world, we'd like to model with logical views only. One, it's going to be better for self-service. It's much easier because you're going to have a lot less views, and those views are going to be much more semantic for your end users. They're going to understand. Like in this example here, we have voter data that we're enriching with some third-party survey data. We have the join, and then we break that out into like an Ohio view and an Illinois view. Very logical. If I were an analyst, I can go in here. I know exactly what that Ohio voters data probably is, and the Illinois data that voter is. Cool. Now the thing is that these are all logical views. So just in a standard unintelligent query system, what's going to happen is that when I query that Ohio voters view, it's going to go back, start over here, reprocess this join between my two tables over here. And then once it's recreated this view, then it's going to do that query on Ohio voters. So I have to wait for that whole chain to happen. Okay, for every query. It's not going to be, so while this may be a more easy, more self-service way to access the data, problem is going to be performance. So what do we do to deal with our performance? Okay, we start introducing the copies. So that enriched voter data, we create a materialized view on it. We actually create a materialized physical copy. So again, those purple data sets are physical copies. So we create a physical copy of that voter data and then maybe create new views on that. Okay, because these new views are based on the materialized view, so they're going to be quicker than the original ones that are based on the view version of the join. But the problem is now my end users need to know that if they query this, they're still going to get that slower performance. They need to query this name instead. So that means either I have to make sure that they understand that, And if they don't, I'm going to have to create mechanisms to make sure that I adjust their queries. So that way I create some sort of system that filters their query. It says, oh, you queried enriched voter data. Let me swap that out for MV enriched voter data. Okay, it just creates more work. And on top of it, we create pre-computed metrics, those extracts, those cubes, to power some BI dashboards down here. And then I got to make sure I maintain those. When they build those BI dashboards, they got to make sure that they target those cubes and extracts. So they have to be aware of them. So the idea is that there's just more the end user has to be aware of. There's more that I'm maintaining. So you break this whole self-service paradigm. It's not really self-service anymore because it's gotten too complicated for that end user to really serve themselves. Okay. I just have to kind of be involved to maintain all this stuff to make it work. So we kind of broken that original goal. We got the performance, but we don't got the self-service anymore. I'd like to get back to that view only world where it was much more self-service, but still have the performance. And this is where Dremio comes in. So now I'm back to where I just have the views, but all I have to do is flip a switch. I just flip a switch here and add a reflection. And now when going forward, these views are going to be much faster to query because instead of redoing the join, it's always going to start with the reflection that was created on enriched voter data. Okay, so it's starting from that sort of materialized result set that Dremio is going to maintain and keep up to date. So basically, once I create that reflection with this SQL recommended by Dremio, I'm good to go. I don't have to do anything else. It just kind of maintains itself. And my users, they're not going to know why. They're just going to notice things are faster. Okay, so again, keeping that self-service feel. They don't need to be aware of all these layers of stuff, nor should you be having to maintain it. Okay, and then over here, the BI dashboards that we're creating on Ohio voters, well, Dremio recommended that I create a aggregate reflection on it. So I run the SQL to create that aggregate reflection. Again, basically now when someone builds a dashboard, they're still just building the dashboard based on the Ohio voters table. They're just going to notice that that dashboard is really fast, really crisp. They don't need to know that all this stuff is happening. Again, I don't have to maintain it. Okay, so it's easier for me, the data engineer, less headaches, so I can go focus on how the quality of my modeling and the expanding the reach of my data. And it's easier for my end users because we have a much more self-service look at the data. And it's much more easier for them to curate views on this, from even further views for their specific use cases from here. So overall, you end up with performance and self-service. It's no longer a trade-off. Okay, it's no longer a trade-off between simplicity and fast. Okay, you can have easy and you can have fast thanks to Dremio. So how would this kind of all work? So like, let's say you were, deploying Dremio today. What would this whole thing sort of look like? Okay, and again, just a little summary. Again, what are we talking about? Dremio is basically eliminating the pipelines, making everything faster, maintaining all these accelerations for you, making everything easy, fast, and open. And because it's open, you can begin by just connecting your sources wherever they're at. So in this example, okay, I have a Postgres and MySQL database, my operational databases. I could connect them directly to Dremio, okay, which may be fine for some use cases. Or I could use something like a Spark or a Flink and then land them as iceberg tables in a data lake, which, can be even, the reason why you would want them as iceberg tables is that when you build reflections on iceberg tables, so basically if I use iceberg tables as my raw data, and then I enable reflections on them, as we talked about before, those get incrementally updated. So basically those get updated even faster. So if you're talking about like having the freshest of fresh data, basically starting with iceberg tables and then building reflections on those iceberg tables are going to allow for like the lightest footprint as far as like updating those reflections, and also the freshest data always available in those reflections. So it makes that acceleration just that much more powerful. So that would be more like low ETL. Okay, so zero ETL, I connect directly. Low ETL, I just land them as iceberg tables and then do all my modeling virtually. But again, I could also upload CSV, XLS files, JSON files directly into Dremio. Maybe I use I have some third-party data sets that I got from like the Snowflake marketplace, or that I got through access through Delta sharing. And I can go access those because Dremio has the ability to read Delta Lake tables, and along with iceberg tables, and has the ability to read Snowflake. So it could read all that Snowflake data you got from the Snowflake marketplace right there, making data sharing much easier. Okay, so if I want to enrich my data over here with data from over here, I just connect it all to Dremio and just bring it all in one place. And then I can model that data. So then I can create folders for each of my business units in the same way you would create a data mart for each of your business units. And I can maybe do a medallion structure, a medallion, what's the word I'm looking for? Well, a medallion structure. So you the bronze, silver, gold. So basically what I'll do is I'll create a view of those raw data sets in my bronze folder. And then, my clean, validate, move that over to my silver folder, denormalize, do some masking of like PII, move that into my gold folder. Okay. And I have that chain of views. And in this case, where it's like right here is where I'd maybe, I see that maybe people will query these directly and these directly. So maybe I'll turn on reflections in this level. Okay. So I never had to create a physical copy of my bronze level. Okay. I can just turn on reflections at silver level, and then Dremio will physically, again, maintain those summaries, those caches, those whatnot, those materializations behind the scenes for you, and swap them out. And those will just automatically, transparently be swapped out when people are querying here or querying there. And again, I can do that for each of these virtual data marts. So the modeling is all done virtually, and then I just turn on reflections where it makes sense. And again, a lot of that can be recommended to me using Dremio's reflection recommendations. Okay, so awesome. So again, building those views requires me to write that SQL. So you remember from a few slides ago, so let me go back to that so you can see that again. I would write these different queries to kind of create those reflections. Okay, it would be nice if I have a lot of views, a really complex model. How do I do that? I mean, I could just go to the UI and generate the views directly from Dremio's UI. I could send SQL queries through the Dremio REST API or through JDBC directly to Dremio. But Dremio also has a DBT integration. And using that DBT integration, I can focus on designing my models and allow DBT to handle what DBT does, handle knowing which tables, which views are going to depend on what other views, and being able to create those views in the right order. And I just focus on actually saying, okay, hey, this view meets this schema, depends on this field from this model over here. And then when I run the DBT job, it will then generate all those views for me. And again, using SQL with DBT, I can create spaces and folders, I can create views, I can create reflections, I can grant, or let me rephrase that. Using Dremio and sending SQL to Dremio, whether through DBT's integration or through one of these other, the Dremio UI, the Dremio REST API, JDBC, ODBC, I can create spaces and folders, create views. Everything can be done via SQL and Dremio. It's just about sending Dremio SQL to do what you need to do. Okay. But once I have all those views curated, then it's just a matter of me granting access to those views. Everything, as the admin, I have access to everything, but all my other users start with zero access to nothing. So what I can do is then grant them different levels of access to the individual data sets that they should have access to. So they don't have to have access to the raw data set to have access to the view on it. And I just give them access to the views that they need. And again, Dremio behind the scenes will swap out reflections that are relevant. So they just get to enjoy the performance. They see what they're there. And the cool thing is you can also write documentation. So now when they see the data sets that they have access to, they can actually read documentation. And there's actually a new feature where you can actually use AI to help generate that documentation. So that way, basically, it'll automatically generate documentation on data sets based on their schema, and make it easy just to provide all that information, to make it easy for users to kind of understand what's going on. But not only can I just say, hey, these users have access at this level, I can create masking rules on the tables that can either filter different columns. So here you see what we do is we create a UDF that has the logic for how we filter the columns, and then we apply that to that table. Okay, you could also do it for rows. Again, we create a UDF that applies the logic for how we filter the rows, and then we apply that to the table. Okay, so I can apply row and column-based masking in a very sort of easy and intuitive way. And then I might have some users who are going to be using BI dashboards on certain data sets. And what I can do is, if I know what those data sets are, I can just flip the aggregate reflection switch. And going forward, they're going to have sub-second query performance when they connect to their favorite BI tools, whether that's specifically with built-in integrations, literally one-click integrations with Tableau and Power BI, but integrations with pretty much any BI tool you can think of. Okay, and you're going to get those really fast BI dashboards because when those queries come in, Dremio is going to know to swap in those reflections, because Dremio can intelligently figure these things out for you. You just worry about asking the questions you're trying to ask. And then that data not only be delivered to BI dashboards, but you can, through ODBC and Arrow Flight, you can pull that into your favorite notebook for things like AI and ML. So here we have an example of just basically running some queries via ODBC or PyArrow against a Dremio cluster right there in your Python notebook. You can build full-on data applications with them. So in this case, using Dremio's REST API, here we have an example of a Flask application that generates an HTML page that visualizes the data. Okay, so basically here we have a backend Flask server or Fast API server that has an endpoint that receives the SQL and gets the results of that SQL, and then passes it onto another page that generates the HTML that basically generates a chart. Okay, and basically you now created a data app to do visualizations of that data. So you can create custom business data applications right off of Dremio across all your data that you have federated and accelerated with Dremio at scale. Okay, so Dremio is very powerful and enables so much. Again, it allows you to bring in your data from everywhere, model it with little to no copies, okay, in a very easy and intuitive self-service way, okay, and then deliver that data anywhere. So you take the data from everywhere, model it easily in the semantic layer, and then deliver it everywhere to be able to be used performantly. Okay, and this takes out a lot of the friction, so you can focus again, as the engineer, you can focus on the modeling of your data, and as the analyst, you can focus on the questions you're asking, so that way you can get data to the analyst faster and smarter, and the analyst can then use the data faster and smarter to generate business insights, to generate business value. So hopefully you guys enjoyed that. Again, my name is Alex Merced, developer advocate here at Dremio. And again, this has been our discussion about ZeroETL and virtual data marts. Basically why Dremio is awesome. And what I'd like to do is what I want you to do is, if you have any questions, put them in the Zoom chat, and then I will make a follow-up video going over any questions that are in the Zoom chat. But with that, I'd like to thank you guys all for attending. I'll see you all soon.